Yo, yo, yo! This is Mr. G coming at you with a video about solving and more about simplifying algebraic expressions. If you have not watched 6.1 part 1, you need to do that first because there's a couple things in there that I'm going to expect for you to have already know. Okay, that's from that video. So, key terms. Let's get into the first distributive property. I'm going to show a bunch of examples of this here in a little bit, but distributive property is multiplication of a factor with all terms inside of the parentheses. So this right here, we're just using it with letters to start, but we'll actually have numbers in there. So I have this a, and we know that like if I have parentheses, like this is 3 times 4. Okay, because we have a number next to a parenthesis, there's no sign in between. So if I have a, and here's a parenthesis right afterwards, right? This is a times, because there's no sign in between, everything inside of the parentheses. Well, we might have multiple terms inside the parentheses. So the distributive property is when we actually distribute that a amongst the other values. Okay? And we multiply it by everything inside the parentheses. We're going to show some examples of that in just a second. Factor. Factor is a number that is multiplied by another number to get a product. We're going to practice factoring here in a little bit, and we'll go over examples of that as well. But factoring is basically the distributive property backwards when we look at it here in a second. So here, over here to the left, right, the top right corner, this would be an example of what distributive property is. So this is an example of distributive property. It's going to look like this. You're going to have a number on the outside of the parentheses, and they're going to have multiple terms on the inside of the parentheses. Some might have a variable, some might not. It doesn't really matter. So when we talk about parentheses, is a lot of people are like, oh, you have to always do the parentheses first. Well, what we're going to ask ourselves is there anything for me to do inside of these parentheses? Can I combine 2x and 4? And the answer is no. Those are not like terms. So I cannot do 2x plus 4 equals 6x or 2x plus 4 equals 6. I'm not allowed to do that. So what this is this is 3 times, there's no sign in between the 3 and the parentheses, so this is 3 times everything inside the parentheses. So what we do is we're actually going to do that. We're going to take the 3 and we're going to multiply it by the 2. We're going to take the 3 and we're going to multiply it by the 4. You're going to do that 3 times everything inside the parentheses. So when I do that, I have 3 times 2 right here, which is 6. And whenever we have the x, let's say if I have 2x 3 times, that means I have 6x. So you really just multiply the numbers and just let the variable tag along. 3 times 4 is 12, and it's positive 12, so therefore I'm going to write down the positive sign to make it look like plus 12. I'm done. I've used the distributive property. I cannot simplify this anymore because there are no like terms. Okay? So let's look at this first one up here in the top left. So there's 8 times 4x plus 3. So positive 8 times 4x plus 3. Nothing I can do in here to simplify. So I have 8 times 4, and then I also have to distribute and have 8 times 3 as well. So when we distribute, we take this 8 and we multiply by everything inside parentheses. So 8 times 4 is 32. Bring down the x with it. 8 times 3 is positive 24. So I'm going to bring down that positive sign to show that it's really just plus 24. And I'm done. If they're negative signs, that's okay. Negative signs don't matter. Then just use your integer rule. So positive times a negative is always negative. Negative times a negative is always positive. We just got to write the sign in front of it because that's going to determine if it's addition or subtraction. So if you guys want, try this one on your own right here. So try this one on your own and see how you feel about it, and then pause the video, try it. It's only going to take you a couple seconds, and then you can come back and see how you did. So negative 4 times 9, so again, distributive property. I'm multiplying negative 4 times everything inside those parentheses. So negative 4 times positive 9, a negative times a positive is negative. 4 times 9 is 36, so that's negative 36, and then the x just tags along. This is negative 4 times, we keep the sign with the value. Okay, so we keep the sign with the value, just like what we were doing when we were combining our like terms. So this is negative 4 times negative 3. Negative 4 times negative 3 is positive 12y. So I have a negative times a negative is always positive. Now, some people say, well, Mr. G, this is minus positive 3y. So if you did that, that's actually okay. So if I did negative 4 times positive 3, so let me go back down here real quick. I'm going to rewrite it. If I did negative 4 times positive 3, that would be negative 12y. And then let's say I just brought down this minus sign. I just ignored it and brought it down. That still gives me a double negative, which makes it positive. So I just keep the sign with the number, and then that's how you know what sign you're multiplying by. Makes it a lot easier so you have to deal with the double negatives. Okay, again, for this last one, try it on your own. There's no reason not to. Try it on your own, see how you do. And then pause it, check it, hit play, check your answer, go from there. So this one, there's 3 terms inside the parentheses here. So that's okay. I'm still going to take this negative 3 and multiply it by everything inside the parentheses. So now I just have to distribute it 3 times. So I have to do distributive property, and I have to multiply this negative 3 times, which is fine. So I have negative 3 times positive 4 is negative 12. Bring down the variable. Negative 3 times 2 is negative 6. Keep the variable with it. Negative 3 times negative 6. I know this looks like a minus 6, but we just keep the sign with the value. That's the minus and the signs tell us what sign the number is. So negative times a negative is going to be positive. 6 times 3 is 18. And I'm done. And again, all of these are simplified because we can't do anything else. I can't combine 12x and 6y because they're not like terms. I also can't combine with 18 because that's a constant and doesn't have a variable on it. Alright, so that's distributive property. Factoring is a distributive property backwards. So right now we already have a simplified expression. Okay, what I want to do is I'm going to divide both of those. I'm going to divide that simplified expression to make it look like this right here. To make it look like this piece. So we're going to go from here to here. Okay, and so I'm actually going to take one of these examples to show you how I can factor it. So if I took this 6x plus 12 here on the right, so let's just rewrite that here. I'm going to write that in the middle, 6x plus 12. And I said, hey, we need a factor. I want to make it look like this. So the way we do that is we look at it and we say, okay, what common factors do 6 and 12 have? So what common factors do 6 and 12 have? Well, 6 and 12 have the common factor they have common factors of 2, 3, and 6. Now, we want to take greatest common factor when we factor these. So let's just say, though, for the purpose of this example, if I took 3 here. So if I took 3, then the greatest common factor, I mean, 3 is not the greatest common factor, so this is not what we want to use, but this is what's going to make it look like this for the sake of this example. So let's pretend like 3 is for this example. So if I took out 3, what I would do is I determine 3 is a common factor, so I can divide these by 3. Now when I divide them by 3, though, I do my division, so 6 divided by 3 is 2x, 12 divided by 3 is 4. But after I do that, I'm going to bring that 3 that I divided by to the outside. So this is really just 3 times 2x plus 4. Because if I had not done that, if I just had chosen to divide by 3, I'm saying that 2x plus, when we factor, it's supposed to be equivalent to each other. When I factor, 2x plus 4 is not equal to 6x plus 12. So I divided by 3, but I didn't maintain equality. So it wouldn't work. So when I divide by 3, I have to bring that 3 back to the outside for multiplication, because multiplication is the opposite. This is the number that I divided by. And I'm back to where I started with up here. It's kind of confusing at first, trust me, I totally understand. So this is one that definitely takes a bit of practice, and so I would definitely pause here after maybe 1 or 2 examples. So looking at 2x and 2, if I wanted to factor this, I want to do distributive property backwards. I'm looking at what common factors do I have with 2 and 2. So what can I divide both of these by? Well, they're the same number, so I can divide them both by 2. So if I divide them both by 2, I'm going to take that 2 to the outside of these parentheses that I'm going to write here. And then what's 2 divided by 2? Well, it's 1. Keep the x. 2 divided by 2 is 1. So I'm done. And then if I actually, this should be equivalent to this. So it's just a different way of writing something. Because now if I actually did distributive property here, it should give me the exact same answer. 2 times 1x is 2x. 2 times 1 is 2. So it gives me the same answer. So I did it right. So I'm done. I factored it. Looking at 3x and 9. So if I'm looking at 3x and 9, what common factor do they have? They have a 3 in common. So I can divide these both by 3. It's very similar to when we simplify fractions. Very similar. So when I divide these both by 3, I'm left with 1x plus 3. And then I bring this to the outside of my parentheses. Now, I'm writing 1x now just to show you that 3 divided by 3 is 1. Is there really a reason to put this 1 here, though? And there's not, because the reason why is 1 times x is just simply x. So I really could write it as 3 times x plus 3. If you write 1x, though, you're never going to be wrong. But there's never really a point to write 1 as a coefficient of x. Try this last one on your own. Just to pause it, try it, see if you can factor it. It's distributive property backwards. Okay, common factor between 5 and 15. So I can divide these both by 5. So if 5 is my common factor, then 5 divided by 5 is 1, so that's just going to give me x. 15 divided by 5 is 3. And then I got to bring what I divided by back to the outside. So I get 5x plus 3. And again, I can always check my answer here by doing distributive property again. So if I wanted to, I could say, okay, did I factor this right? Well, let me distribute this and see what it comes out to. 5 times x, well, that's 5x. 5 times 3, that's 15. Oh, cool, I got the same answer. They should be equivalent, so you can always check by doing distributive property. All right, that's it. So for distributive property, maybe do a big example here. Let's do a big example of what it looks like again. And then put the word multiply up here. Okay, so that's distributive property. And then independent practice, you have 2 problems. You have to factor one, and you have to do distributive property on the other one. So definitely work these out. And that's all I got for you guys. So I hope this video was useful. I hope you guys took your time and you got some good notes down. I hope that you tried some examples on your own. And if you guys have any questions, please do not hesitate to ask me. All right. That's all I got for you. Hope you guys have a great day. Thanks for watching. Rudius out.